Production and propagation of sound. Sound waves are everywhere. Every day, we hear sounds originating from various sources, like bells, birds, musical instruments, etc. Leaves rustling in the wind, humming of a bee, or a plate crashing on the floor. All make sounds. Sound is a form of energy that travels in the form of waves and produces a sensation of hearing in our ears. Let us see an activity. Take a tuning fork and set it vibrating by striking its prong on a rubber pad. Bringing it near the ear, you can hear a soft sound. Again, set the tuning fork vibrating by striking its prong on the rubber pad. And touch one of the prongs of the vibrating tuning fork with your finger. You can feel a sensation. Now, suspend a small pith ball by a thread from a support. When we touch the ball gently with the prong of a vibrating tuning fork, it can be observed that pith ball starts moving to and fro because of the vibrations of tuning fork. This activity shows that the sound is produced by the vibrating objects. We can all produce sound by plucking, scratching, rubbing, blowing, or shaking different objects. It can be seen that plucking of a wire produces sound. In the same way, when a guitar string moves to and fro, it produces a series of sound waves. When we hit a drum skin with a stick, some vibrations are generated in the membrane of the drum. It is the vibrating membrane that produces sound. Here too, the sound is produced as it was produced when a string of a guitar was stretched. When we blow into a flute, it also produces sound. Here, sound is produced by a vibrating air column. In the human beings, it is the vibration of the vocal cords that produces the sound. When a bee flies nearby, we hear a humming sound. It is due to the vibration of the wings of the bee. A source of a sound is always in a state of vibration. Most of the music is produced by the vibrating strings of various musical instruments and their vibrating air columns. In simple words, sound is vibration. Vibration means a kind of rapid to and fro motion of an object. A tuning fork is capable of vibrating if struck on a rubber pad. It is a metal object consisting of two prongs formed from a U-shaped bar of elastic metal. Most commonly, we use steel. As the prongs of the tuning forks vibrate back and forth, they begin to disturb surrounding air molecules by passing on their energy to adjacent air molecules. This makes the air vibrate. The matter or substance through which sound is transmitted is called a medium. In fact, sound requires a medium to propagate further. Sound cannot travel through vacuum. Sound moves through a medium from the point of generation to the listener. When an object vibrates, it sets the particles of the medium around it to vibrate. The particles do not travel all the way from the vibrating object to the ear. A particle of the medium in contact with the vibrating object is first displaced from its equilibrium position. Then, it exerts a force on the adjacent particle, as a result of which the adjacent particle gets displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process continues throughout the entire medium, with each particle interacting and causing a disturbance to its nearest neighbor. The disturbance created by the source of sound travels through the medium in the form of waves. A wave is a disturbance that moves through a medium when the particles of the medium set neighboring particles into motion. The particles of the medium do not move forward themselves, but the disturbance is carried forward. This is what happens during propagation of sound in a medium. Therefore, sound waves are made of particle of the air or the particle of the medium through which they are moving. Sound waves are invisible waves, but these are similar to water waves. One can visualize the formation of sound waves just like water waves. We drop a stone in a pond of still water, the water surface gets disturbed. The disturbance does not remain confined to one place, but propagates outward along a circle. It gives a feeling as if the water is moving outward from the point of disturbance. If we put an empty bottle on the disturbed surface, it can be seen that the bottle moves up and down but do not move away from the center of disturbance. This shows that the water does not flow outward. Rather, a moving disturbance is created. Similarly, the sound moves outward from the source without any flow of particle from one part of medium to another. This activity suggests that the disturbance moves from one point to another, and the energy also moves from one point to another along with the disturbance. In the same activity, we have also observed that a small empty bottle on the water surface moved up and down and remained where it was without any net displacement. This suggests that the energy or disturbance moves in the form of wave without any displacement of a medium. Suppose you and your friend are on the moon. Will you be able to hear any sound? No. We cannot hear any sound on the moon because there is no air. Air is the most common medium through which sound travels. Sound also travels through water, through solids such as wood, iron, and so on. A person can hear the rubbing sound of his own finger. This example shows the propagation of sound through the air. Two pieces of stone are being rubbed together under water inside a bucket. Here, the sound of the stones being rubbed is propagating through water. If we place our ear on a railway track, we can clearly hear the sound of a distant train moving on the track even from a few kilometers. This sound propagates through the solid metallic railway track. Sound produced by hammering on a metallic piece also shows the transmission of sound in solids. Sound cannot propagate without a medium. That is, it cannot travel through vacuum. To justify this, keep an alarm clock covered with an inverted bell jar. The alarm is clearly heard when it rings under normal conditions. Now, if we gradually exhaust the air out of the bell jar through a pump, a partial vacuum is created in it and the audibility of the sound decreases. This shows that the sound cannot travel through vacuum. The sound comes back if the air is pumped in again. This simply proves that sound needs a medium for its propagation. Since sound wave is a disturbance which is transported through a medium via the mechanism of particle-to-particle interaction, therefore, a sound wave is characterized as a mechanical wave. There are two types of mechanical waves: transverse waves and longitudinal waves. Both of these wave types are traveling disturbances, but they are different because of the way that they travel. A transverse wave is a wave in which particles of the medium move perpendicular to the direction of the motion of the wave. Here, a string is tied to a fixed end. When a disturbance is imparted at the free end by vibrating its end up and down, the disturbance or the wave pulse propagates through the string from left to right. But the particles of the medium get displaced upwards and downwards. Here, the particles of the medium move perpendicular to the direction that the wave pulse moves. Whereas a longitudinal wave is a wave in which particles of the medium move along the direction of the motion of the wave. Here, a slinky is tied to a fixed end and stretched out in a horizontal direction. When a disturbance is imparted at the free end, by vibrating the first coil left and right, the disturbance begins to move through the slinky from left to right. But the coil moves leftwards and rightwards. Particles of air also vibrate back and forth. This back and forth motion of the particles creates regions within the medium, where at one region the particles are compressed and at the other region where the particles are spread out. Longitudinal waves are always identified by the presence of such regions. In this case, the particles of the medium move along the direction of the wave pulse. It can be noticed that transverse waves involve change in the shape of the medium, whereas longitudinal waves involve change in the density or pressure of the medium. We know that the shape of liquid and gases can be easily changed. That is, if the shape of liquid or gas is changed, it does not regain its original position. Therefore, transverse wave cannot propagate in liquids and gases, but longitudinal waves can. Hence, transverse waves can propagate through solids only, whereas longitudinal waves can propagate through solids, liquids and gases. When the sound wave passes through a medium such as air, the particles of the medium move back and forth along the direction of the propagation of the sound wave. Therefore, sound waves are longitudinal waves. When a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure and high density. This region is called the compression. This compression starts to move away from the vibrating object. When the vibrating object moves backward, it creates a region of low pressure and low density. This region is called rarefaction. When the object moves back and forth rapidly, a series of compressions and rarefactions is created in the air. In this way, sound propagates in the medium.